Hello, my name is Litvinenko Arkadiy. I'm lead penetration tester in Russian company that has name Bi.Zone. Also, I'm organizer, one of organizers of Russian conference of Zone that in Moscow, yeah, and one of organizers of CTF Zone competitions. It is CTF, and also equals of DevCon CTF. So today we will talk about online banking security. And firstly, among projects on my job, I have a lot of security audits of different online banking applications. And during these projects, I met and we met a lot of different vulnerabilities and other interesting things. So in these presentations, I want to share with you some experience that I got and some interesting things. And this talk will be interesting for offensive and defensive specialists that work with online banking applications. And also it will be interesting for developers who work with online banking, yeah, and who is trying to make it safer. So but I tried to make this presentation with growing difficulty level. So I hope everyone can get something new from this presentation and get something interesting from this presentation. So let's talk about the structure of this presentation, about what we are going to talk about. So firstly, we will talk about differences about remote banking and online banking, and what is remote banking and what is online banking. We will talk about web banking, mobile banking, what differences between them, and after that, we will talk about testing approaches, yeah, and how to test web, mobile, and server side of mobile banking, and what differences, what guides we can use for this, and we usually do use on our projects. So, and the biggest part of this presentation, it will be vulnerability examples with detailed information, how it works, how to exploit it, and maybe some bad practices of fixing it, of avoiding it, and so on. And also we will talk about best practices of how to avoid its vulnerabilities. So let's begin from the differences. Um, what is remote banking services? It is when the client doesn't need to go to the office to do some actions in bank. For example, for transferring money, for I don't know, checking the balance of the account and some other things. And so it can be anything. It can be ATM, it can be call center, it can be SMS banking, and also it can be web and mobile banking. Yeah, and for example, we're going to get cash from the account, so we come to ATM, and it is one of the example of remote banking services. Yeah. But there is another type of banking services. It is online banking. Yeah, it is not another. It is part of remote banking services, but it is a thing that we are going to talk about today. So online banking, it is web banking and mobile banking. Yeah. So web banking, it is when you open the website of bank on the browser and do some actions, and for example, log into your account and do some actions, maybe transfer money, checking balance, and other. So in mobile, it is totally the same, but you have to download the application to your mobile, and after that, you log into the account and do some actions, and so we're going to talk about online banking, about web and mobile banking, yeah. And so we're going to, and all vulnerabilities will be related to these types. So let's talk about how does it work. It is very simple image, yeah, but it is good image for showing that we're going to talk about. We are not going to talk about infrastructure of bank infrastructure, about processing and other very, very complex things. It is magic for us today, and it is it is like black box for us. And so we're going to talk about the server side, about the API. Yeah, we're going to talk about the front end and mobile. Front end, it is the something that loads in the browser of clients. So it can be Angular, it can be React application, it can be HTML with AJAX request, but it doesn't work like this now. Usually, maybe there are banks with AJAX requests, but I don't know. Didn't meet it. So mobile, it is totally the same, but mobile application, it is like a custom-made browser, and front end and mobile, they work with API, yeah, with server side, and they send requests to API, and they get requests from API, and they render it. They show UI to the clients, and the clients can work with this UI and do some actions, maybe clicking the buttons and other things, and enter maybe some. And so usually in banks, API, it is similar API for the front end and the same API for the front end and for the mobile. Sometimes maybe there are differences. Maybe it is split API, so different API for front end and different API for mobile. But usually it is the same. And API, it is like something between. It is an application that helps us to work with bank infrastructure. It has API methods, it has some functionality that can be used by front end and that can be used by mobile. And after that, it sends to bank infrastructure, and there is some magic in bank infrastructure. The bank infrastructure is very, very complex. It can be anything. It can be monolith, it can be microservices, yeah. And so, but today it will be bank infrastructure and API, it will be server side for us. So, and I think it is all that I wanted to say about how does it work. Again, it is very, very simple, and we can't talk more detailed because it needs a lot of time. It is huge topic. So testing approaches of server side and bank infrastructure, usually it is API, it is usual web application, yeah, and bank infrastructure, it is a very complex thing. It is like Zoo with different services. It can be anything, and so it is very hard to hack it without understanding how does it work. And so you can only can try to maybe fuzz it, use fuzzing and other things, and try to understand how does it work. And it is only one way to understand how to hack the bank infrastructure. So API, it is usual web application, so it can has any web vulnerabilities. So if we're talking about the possible vulnerabilities, like I said, it is usual web vulnerabilities. Yeah, it is everything from the AWASP. Yeah, you just can take the checklist of AWASP and any vulnerability and the most related to the server side. So also it is misconfigurations. It can be anything like Nginx misconfigurations, maybe other things, and also it is logical vulnerabilities because the bank and the mobile banking and online banking, it is very, very complex thing. Yeah, it has very, very complex architecture. Yeah, and so when architecture is complex, developers can do a lot of mistakes on this. And so it can be any logical vulnerabilities like IDORs, like I don't know, leakage of sensitive data of clients, maybe if it's correctly to say race condition, but it is not logical vulnerability, but sometimes it can be based on logical problems. So and other vulnerabilities, it is only examples. So It can be anything. Next one, it is front end. So it is user interface, yeah, based on the data received from API, and and because it loads in browser, yeah, browser take a lot of security job on itself, and it is very big difference between the mobile application, yeah, and front end, because browser do a lot of security job by itself. But in mobile applications, developers have to do the things by itself. So and possible vulnerabilities, it is XSS, it is I don't know, DOM-based XSS, it is CSRF, yeah, maybe forgotten or maybe unfinished pages. Yeah, sometimes, for example, developers make and publish in production React application, but this application has pages that doesn't work and they invisible for clients. But anyway, they exist in production, and so after understanding and maybe like reversing of React application, yeah, you can find this and you can recover the methods, API methods that application sends to API and gets, and it allow you to try more requests and maybe find another vulnerabilities. And also, it can be unsafe communication with API server, sorry, and it is everything about SSL. It is everything about communication, maybe other algorithms, and so on, so on. And again, it is only examples. Maybe there are another ones. There are another ones, of course, there are. If we're talking about mobile testing approaches, yeah, like I said, mobile, it is an application. It is like custom-made browser. So, and in this case, you have a lot of, I don't know, security and customization features. Yeah, and so you have a lot of possibilities to do something wrong. And in this case, possible vulnerabilities, it is storing of sensitive data. Yeah, and we will talk about this in one example a little bit later. So also it is unsafe handling of external data, and because there is one good example of vulnerability when mobile application got external data, and save it to SQLite database. So, and there was SQL injection in this. And if you can sniff and if you can edit traffic that application got from the application gets from the network, yeah, you can do the SQL injection on the client side. It is very interesting thing. So also it is unsafe work with mobile platform. It is, for example, IPC mechanism and other things maybe. And also there are a lot of different things. And let's talk about testing guides, testing approaches for every type of online banking. Yeah, for web banking, in this slide, I wanted to make the big table with comparing of different guides and with choosing the best one. But no, I just didn't find any other good guides except Avasp Web and Avasp MSTG. So maybe you know, and if you use something else, you can maybe share it in comments. So it is really good because, but for web banking, we also usually use Avasp Web. Yeah, it has very good checklist and it has a lot of different vulnerabilities. So it is really great and good job of someone who made this. Yeah, of people who made this. And so mobile banking, it is AWASP MSTG and AWASP Web guides. And AWASP MSTG, it is about everything that's related to mobile platform. Yeah, all vulnerabilities that's related to this one. And why AWASP Web here? Because we have server side, yeah, and when we watching the mobile application, we have to check the platform, yeah, the application, and also we have to check the server side and how it communicates between the how it communicates with the mobile application. So for the platform, for the application, we use AWASP MSTG, and for the server side, we use AWASP Web, and it has maybe some intersections, yeah, and so if in the best way this intersection should be fixed, yeah, and you have to, and the best way is to have the one big checklist and one big guide. And so using of these checklists is very conveniently, and it is really helps us to don't forget something when we test it. So after that, we begin to talk about vulnerabilities, and now it is the biggest part, and we will talk about this for the until the finish of the presentation. And firstly, I want to say why I choose this vulnerability. There are three options, and there are three reasons why I choose this. Firstly, it is, for example, some vulnerabilities are very common. Yeah, you can meet it in a lot of different applications, and it is very common. And this is problem. So the second one reason it is because this some vulnerabilities are really interesting, and they are not common. Yeah, maybe it is very rare vulnerability, but anyway, it is really interesting, and it is like really hacking. And for example, like I said before, it is like making money from nothing. Yeah, and so on. And so it is really interesting, and I love it because. And so the third one reason it is because sometimes some vulnerabilities are really hard to fix. Yeah, and developers trying to fix it and make another vulnerability. And so we will talk about I don't remember one example of this vulnerability. And so it okay, a little bit later we will talk about it. So let's begin from the first one, vulnerability. And first vulnerability, it is rounding attack. It is currency rounding attack, and you know it is one of my favorite vulnerability because it is really like hacking. Like I said before, and I talk about this vulnerability. It is like making money from nothing. Yeah, and so first information that I found about this vulnerability, it was 2011, maybe 2012. Maybe there are early information, but I didn't find. So this vulnerability based on the incorrect on unsafe using of round functions. Yeah, and later we will talk about example. But now very simple example of using of round functions, and it is very simple. But for us, interesting last example when we can in round function we can set what is we can set the decimal places that will be after rounding. And as you can see on this example here, um, it is two decimal places after rounding. So after rounding, we will get 1.52. Yeah, and so you can say that it is not real vulnerability, and it is not possible to meet it in real life. But and for example, all banks already fix it, and all companies that work with money already fix it too, and you can't meet it in real life. So, but no, there are examples, and you can you can find it on HackerOne. And you know, I met this vulnerability 2 years ago, and you know, one very huge bank. And so no, examples exist. So let's watch the example. Yeah. For example, we have one account, yeah, and this account has two wallets, USD and Ruble wallets, yeah, and you can transfer money between these wallets. And when you transfer money, the different currencies converts in between, yeah. And for example, in this case, we have unreal rates, but anyway, it is very comfortable for us. It is for calculations. So current rates, it is 64 for 64 rubles for $1 in case of bank, and the same 60 for 1 USD in case of selling. And so we have bank that use rounding to decimal places. Yeah. And our goal is to become rich. So what we can do? Let's watch the attack. Yeah. We have uh, 1 second. We have one ruble, sorry, on the ruble wallet, and we send it to the USD wallet. And after rounding, yeah, firstly we convert it to the USD, and after that calls function rounding, and as a result, we will get 0.02 USD from 1 ruble. Yeah. After that, we convert, we send this 2 cents back to the ruble wallet. Yeah. And it will be already 1 ruble and 20. Yeah. And now we have profit 120%. Why it happened? This has happened because of this. This is main reason. So we had the one number, and after wallet it became more. Yeah, and this difference is very critical, so we can get a big profit. And you can say that now we have 2 additional ruble cents, yeah, and it is not rich, yeah. But if you can repeat it 1,000 or maybe 1 million times, you will get real money. I think banks not allowed to make this a lot of time because anti-fraud and some other things. But anyway, if this vulnerability exists, someone can try to exploit it, and it is, I think, the best way to fix it anyway. Um, and I have very simple plot. Yeah. Firstly, on the X, we have transfer amount rubles. Yeah. And the Y, we have on the Y, we have profit and the persons. Yeah. And so, as you can see, the biggest profit when we send about, I don't know, 0.3, 0.4 rubles, yeah, to the dollars, to the USD. And in this case, the profit the highest. Yeah. If and as you can see, if we send more, yeah, the profit less, and after some specific moment, it is less than 100. So it is non-profitable for us. And from this, you can see that it is first way to how to avoid this vulnerability. It is set the limit of transaction. For example, if we'll set the limit of transaction in 6 rubles, yeah, it will be unprofitable for anyone who tried to exploit this vulnerability. So also there are two another ways, and second one, it is that we shouldn't allow to clients to convert money from rubles to USD. Instead of this, we should allow to buy USD. Yeah, for example, client will buy 0.01 USD, and and after that client will get a price, and after that they can finish the transaction. So in this case, anyway, there is rounding, yeah, and it will be. But in this case, numbers are higher. The numbers are bigger, sorry, and it will be unprofitable for anyone who is trying to exploit this vulnerability. So, and there is another way. It is at adding commission after certain number of transaction. It is not looks like good way, but anyway it works, and so but it looks like not like good fix. So but this vulnerability that I found, this rounds attack took 2 years ago, the bank fixed this by adding commission after specific count of transactions. So on another example, it is sensitive data disclosure. It is very common vulnerability that is you can meet in every and a lot of application, not every but a lot of, but maybe in every, I don't know. Let's watch an example, very good example, very interesting example. And this example shows that is what is convenient is not always safe. So we should look for balance between convenient and for between security, and it is very important. And case the bank added functionality that allowed to send money between cards and between cards, yeah, without login procedure. Yeah, so it looked like this. So user enters firstly information about source card, yeah, about their card, and after that user enters the information about the destination card. Yeah, it is only PAN code. And the first step, we enter the PAN, CVV, and expiry date. So on the second, only PAN code. So on the third step, user enters the amount of money for transfer. Yeah, and on the next step, system checks the balance and calculates the commission. And if everything's okay, money is enough, and so on, user gets SMS. Yeah, the user that has the source code get SMS, and after the entering the code, the transaction is done if code is okay. So let's watch into the HTTP request that was used for checking the balance. Yeah, and it is the was problem. The main problem was that this server didn't check the expiry. 1 second, the expiry date, and didn't check the security code. Yes, so but it checked the money amount and card number. So as a result, everyone could get any could get balance for any card in bank. So just by enumerating the card number, just by enumerating the money amount. So so it worked like if you set too money too much money, yeah, server will return the error that money is not enough. Yeah. In other case, it will be everything's okay. Enter please code. Yeah, please enter the code. So and you can set any card number, so you can get information about every card in bug, and it is not so good. Now it fixed it. Next vulnerability, it is unsafe OTP. Firstly, what is OTP? OTP, it is one-time password. And it is usually one of the most popular realization of second factor. Yeah, for example, you enters to the mobile banking. Yeah, you enter your login and password, and after that you get the SMS code or maybe push notification or maybe something like this. Yeah, and you have to enter it to to pass the second factor of authentication. And usually it delivered via SMS. Yeah, and it is the most popular way for delivering. So let's watch an example. Yeah, we are hacker. Yeah, and we got access to user account. And so we want to get money of this client. So we have to send this money from our account to the from not no 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 from user account to our account. Yeah. So, for completing this transaction, we have to enter the correct OTP. This OTP sends to the mobile of this of the client and the owner of this account, and so we don't know this OTP, but we have to enter it. And so, after free and correct, and every time when we create a transaction, we have only 3 tries. Yeah, after free incorrect entries, transaction will be cancelled. And OTP has 4 random digits, yeah, digits, and it is, for example, 1, 2, 3, 4. Yeah. Um, so how to make this transaction? How to finish this transaction? Uh, it is like little bit strange, but what if instead of brute forcing OTP, yeah, we will try to brute force transactions? Yeah, what if it will be not brute forcing, but it will be guessing? Sounds strange. I'll explain. Okay. Um, Very important thing. If we're not limited in the number of new transactions, if we can create and create and create and so on, yeah, we can try to next exploitation. We choose 3 different OTP. Yeah, uh, it should be potential correct OTP 1, 2, 3, 4. I don't know, 5, 5, 5, 5, 6, 6, 6, 6. Yeah, and after that we create new transaction and try choosing OTP. Yeah. Uh, if it isn't correct, back to step 2 and create new transaction. But on this moment, it is, but every transaction, it is regenerate the OTP. So we can just brute force it. We can just take the one big dictionary, yeah, and using this dictionary to enumerate, to brute force all existing OTP. No, it doesn't work like this, but it is very, very similar, yeah. So, and we should repeat this algorithm, this exploitation until we matched at least one OTP. If we matched the at least one OTP, the transaction will be finished. Yeah. And so it is one big difference. It looks like brute force, but it isn't brute force. It is guessing. So in case of brute force, we know about the when it will be finished. For example, dictionary has size 10,000 lines, so it will be finished after trying of 10,000 lines. So in case of this, brute force, yeah, but it is guessing. We not sure when it will be finished. It can be finished after on the next transaction, or it may be it can be finished after 20,000 of transactions. Yeah, we guessing. We're trying to enumerate the transactions. Yeah, until we until the generated OTP didn't match our OTP. So I'll explain everything. No, I'm joking. I am not going. It is boring. So no, no, no. But it is very interesting results. Let's watch on the results. So probability of the successful transaction depends on the number of attempts. So in our guessing exploitation, yeah, after 3,000 attempts, it will be about 60% probability, yeah. But if we can try 16,000 attempts, it will be 99%. So it is a really good result, I think. And let's watch on little bit more complex example with new limitations. The same example, totally the same OTP, totally the same situation and so on, but after 5 cancelled transactions, we can't create new one. We will be blocked for several times, for example, for 24 hours. Yeah. And so what we can do in this case? There are 2 possible approaches. First approach, it's we totally the same exploitation, totally the same steps, but we try not 3 OTP for each transaction, but 2 OTP. So in this case, we avoids the cancellation of transaction. And in this case, creation of transaction will not be blocked. Yeah, so it is one approach. Another one, we can, in the beginning, create the several thousand of transactions. Yeah, for example, we can create 20,000 of transactions, and only after that, we will try the OTP. So in this case, yeah, we will block the creation of new transactions after trying the OTP. Yeah, but it is not affected. It doesn't affect us because we already created the 20,000. And as you can see from the calculations, in case of 20,000, it will be more than 99% probability of success. So we will get profit. So and also, very good question. Is SMS a secure way of OTP delivery? Yeah, it is good question because there are a lot of attacks against the SMS. It can be fake BTS, it can be reissue of SIM card, it can be SS7 attacks. Yeah, for example, these two very cheap things. It can be used for creating the fake BTS, for creating the fake station, yeah. And using this, you can try to attack the client and the. So let's talk about the recommendations. Yeah. Firstly, second factor should be enabled for all critical actions. Yeah, if you, for example, log into account, if client, for example, logins to account, for example, if changes changes the profile information, maybe other critical actions, it should be client should enter the second factor. Also, it is very important to limit the count of requested OTP. On the previous examples, we tried to limit the creation of transactions, but sometimes it is a little bit hard. Maybe you can make another vulnerability and so on. So the best way is to control the OTP. So how many OTP, how many generation OTP client asked. Yeah, and after specific count, just stop this process. And also, maybe it is a good way to think about alternative for SMS because SMS not looks like the best way for delivering OTP. For example, we can watch on the push notification, we can watch on the TOTP and HOTP. TOTP and HOTP, it is, for example, Google notification, it is Microsoft notification, it is application that you have on your mobile phone, and they use cryptography for OTP process. So but every alternative has another problems. For example, TOTP and HOTP has very big problem. It is totally silent because it is not like it doesn't have delivering. Yeah, so client doesn't know about that someone trying to brute force its second factor. Yeah, and so. Sometimes it is very critical because in case of SMS or maybe push notifications, client will get a lot of messages about that and understood that something wrong, and maybe call to support, and support will call to security information specialists, and so maybe attack will be stopped. But in case of TOTP and HOTP, it doesn't work like this. Next vulnerability, it is unsafe randomization. And it is, you can meet it in application where logic is based on the generation of random values. It can be sessions, it can be OTP, maybe unique identifiers. Yeah, and it is for example, most common problems it is using of unsafe, predictable random numbers generators. Yeah, in other case, it can be, for example, using the predictable functions for creating the, for example, sessions, maybe unique identifiers and so on. So in a case when attacker can recover the sequence of random values. Yeah, and it can be in case of, for example, incorrect initialization of pseudo-random number generator and so on. And it is one very known example when it isn't online banking, of course, but anyway, Russian engineer they with the but it wasn't one engineer, it was team. Okay, never mind. A team of Russian engineers, or maybe one engineer, reversed the slot machine, yeah, and they recovered the sequence. They recovered of algorithm how it used for used randomization, yeah, and they developed the program. Or I don't know what they did, but they, for example, they developed the program that helped to recover this sequence. For example, they came to the slot machine. They played for several minutes, and in these several minutes, they got the sequence what slot machine showed to them. Yeah, and using this information, they recovered the all sequence all of random, and they can and they know what will be in the future. And so using this cheat, they can they did a lot of money. And so it is one of the good examples. And so another one good example I heard from Timur Inusov, and he met it is on his project. So it for OTP generation was used LCG generator, yeah, for randomization. So, but using of LCG is not okay because it is not cryptography safe. And for example, when you have sequence of several generated codes, you can recover all sequence. So you can predict next OTP codes. And for OTP, it is very critical. So something like this. Another vulnerability, it is mobile banking authentication. Yeah, it is not vulnerability, but it is like evolution, yeah, for mobile banking authentication. I'll explain. Okay, for example, we have case client installed our mobile banking application on the mobile phone. Yeah, and client very good client. Yeah, they know a lot about security, and so client has very strong password. Yeah, and on the mobile phone, and a very strong password is not convenient. Yeah, and it's not so comfortable, and so mm, our task is to develop the simple authentication process, and that works after first login. For example, first time a user enters the login and password. After that, something happens, and user can enter the more simply. Yeah, for example, using pin code or something like this. And so let's try to make this solution. Yeah. Firstly, what is the most simple way? After entering the login and password, yeah, application just save the user password to file, and every time when a user opens the application sends the password to the server and get the session, a live session. It is awful. It is totally unsafe because of the saving of password. It is awful practice by design. Do not do this. It is awful. The second problem, that unlocked device provides access to mobile banking. So anyone who can take the who can get access to unlock device, or maybe device doesn't have pin code by because it didn't set. Yeah. So in this case, anyone can just use the mobile banking. It isn't okay. And so finally, the second factor doesn't help in this case because this phone has the SIM card and the SMS will be on this phone. So and this third one, the hacker can get access to the file with password. Yeah, and in case, for example, if application has vulnerabilities, yeah, or just because of hacker has hacked the phone and now has root access. And in this case, hacker can just open any file on the file system almost. So another case, after successful login, yeah, user sets the pin code. Yeah, and pin code saves or maybe not saves, but it used by checking the access by application. Yeah, and for example, the refresh now we use refresh token. Yeah, and I forgot to say that the best practice using not password for save not password, but save the refresh token. Yeah, and using the refresh token for creating a live session. So after first login, yeah, user set pin code. This pin code used for decrypting the encrypted refresh token. Yeah. So and also this pin code used for checking the access. So you open the mobile application, you enter the pin code. Pin code, for example, comparing with something, yeah, and for example, decrypting the refresh token. The refresh token sends to server, and server backs session, a live session. Yeah. Again, it is awful realization because of firstly, anyway, we store the refresh token in the file. So hacker again, if there are vulnerabilities or if hacker have root access on the mobile, hacker can just get access to file with password. In another case, encryption of token with short pin code is useless because pin code is very short and brute force of this will be very fast. And also any local checks like pin code check and other things can be easily bypassed by Frida if you have enough access on the device. So it doesn't work like this. So next realization, we save refresh token to the KStore keychain. Yeah. And you know, KStore keychain is the very good option. And but it is unsafe only in one case when we enabled the checking of biometric open code when someone opens this record. In this case, hacker can't get access to these records in keychain. In another case, if no access checking, and the application just extract the data from keychain keystore without any interactions with the user. In this case, it is totally unsafe. Not totally, but unsafe because of a hacker with root access can just extract it without any problems. So also it can be problematic if a user has old device. And in this case, maybe problems with KStore keychain, maybe just device don't have enough security functions and so on. And also, but it is very similar to the second one. The third one is that you completely dependency on the KStore keychain security. So if there are some problems with this, you have problems with the application. So like this. And the last one realization, application asks user to set pin code, and this pin code will be sent to API. So API controls the authentication process, and in this case, you can control the anything like brute force, like enumeration and other things. So you can control anything. And in this case, it is totally the same. And for example, in case of using KStore keychain, you can't set, user can't use any pin code because of it will be pin code of device only. Yeah. In case of the last realization, user can use any pin code because it is no limitation. And we can set, for example, we can ask for the big pin code like 6 symbols, maybe 8 symbols, any pin code, yeah, and other things. But it is very important to that now we have to protect our server side because everything depends on our server side. That's all that I wanted to show you. And so now about conclusions. Yeah. Firstly, there are good testing guides, there are good testing approaches, and you can use it not only for testing the applications, but you can use it for developing the application, for making applications. So, and it is really useful. It has a lot of examples and so on. Also, next conclusion is sometimes convenience is the enemy of security, and as you can saw from the example, yeah, third example with bank that added the functionality of sending money between cards without login. It is sometimes too critical, yeah, and so it is very important to find the compromise between convenience and between security. Next one, it is be careful with cryptography, randomizations, and other things, because cryptography is really complex, and it is very important to understand what do you do. And just don't use cryptography without understanding. It is bad practice. And the last one conclusion is use best practices and use experience of other companies. Watch on other products, watch on other applications, because a lot of problems, yeah, and a lot of some companies already solve these problems. And if you found and if you find the correct solution, will be very good. And so it is everything, everything that I wanted to say. So thank you for attention. I hope you got something new from this presentation. Thank you.